Hello, welcome to another episode of the TinyGo code review. Today we'll be looking at two pull requests which have been submitted to the TinyGo dev Slack channel. Without further ado, let me show you guys. All right, here we are. This is the TinyGo dev channel in the Go for Slack. The link is in the video description if you want to join in on the discussion, see what's happening. All right, and the first one is, I think we're going to look at this one first. It's got the most juiciest changes. And I've already started a review, haven't really gotten around to sending it because there were so many things I wanted to talk about. And I thought maybe a video form of the review could be a bit more palatable and expressive than text. I find that it's easier for me to just find the time to make a video rather than, and besides a video, I can upload this to YouTube where you're probably watching it and it might be a learning resource for anyone who comes across it. So what do we have here? Oh, let's read the pull request information. This PR is to improve the GPS implementation for the use of structured UBX config commands. So there's this new concept, UBX, it's got config commands. I'm thinking this is probably going to be sending data over the IO interface of the GPS. Well, let's see what we got. First, let's look at files that changed, and so I can more or less find my bearings. I'm gonna minimize them so I can just get an idea. So the UBX, ublocks, these are new. The ublocks already existed apparently. And minor changes to gps.go, gpsparser.go, blah, blah, blah. Well, let's start with ublocks. This is a new file. All right, so flight mode CMD. And the first thing that sort of catches me, is this thing like pre-existing? So this is the part of the new PR. It's in the UBX. You got ublocks and UBX. Not sure what the difference is, why we've split them up in, first of all, like UBX. So we've decided to split them up in two files, ublocks and UBX. And ublocks has some variable definitions. So the first thing that comes to mind, global variable definitions. This is a pattern I'm not a big fan of. I've seen like one of the few times I sort of actually do this is with errors. So, you know, your typical use of these are like io.eof, right? So this is a variable. In Go standard library, we usually find errors as global variable definitions because people, you know, use them as such. But lately I've been finding I'm not a big fan of this either. And in my latest changes to my networking library, I've opted on using constant error definitions. There are reasons not to do this, but I find, I don't know, I'm not sure why we don't do constants in Go for error definitions. I'll get back to you, you guys, afterwards on that one. But for now, let's look at this PR. So we got variables. These are structs. So I feel like even less reason to do this when you have structs. So I definitely rewrite this as a function, like flight mode CFG nav5, and just, you know, boom, return. Because why are you? I mean, this provides the same functionality, and you are guaranteed that no one's going to be touching up your global variable. I mean, this is what we generally do, right? Like http.default configs are something that we commonly do in Go. Like, I feel like this would be a better approach to the same thing. All right, let's continue. Set flight mode. This is a very odd function. Flight mode CMD, right? So yeah, this writes to a buffer. Definitely should check here. And this is not right. This is more of a put method, right? You're not writing here. You're putting data into the buffer. And if the buffer is incorrect in length, it's going to panic. So put fits that bill much better. I mean, if you're going to return an error, at least return an error, you know, if len buff less than 42 turn you're gonna. And so if we look at the put functions in the endian binary package, these don't return an error because the author is expected to know, you know, UN16 is 16 bits in length, 2 bytes, and if they don't check beforehand, it's gonna throw a panic. And we could have the same approach in this library where we have put methods that panic, they don't return an error, and then have this, and then have, okay, func, CFG nav 5, then have write, or append even, DST, byte error, right? And this is sort of a bit more in line. So write DST, write, and these actually do return errors, and we do check the lengths, and we can always have this put method for people who know that they're going to be, and it's going to be actually buff. And the put method, you know, is for people who know the length of their buffers. This is, I think, just better in every way, since you're actually like checking your errors, you're actually panicking, you're actually like telling your user, hey, this is going to put into the buffer, and it doesn't return anything. So the user is used to writing code with the binary packages. They know this is going to panic. And maybe we can even help the person out with the length in bytes, you know, put 42. That depends on your taste. I think it's explicit, but it's also like more text. Put 42. What does 42 mean? Is that the answer to life? Put 42 bytes. Put 42 bytes. I think this is good, actually. And then we have the erroring methods. So that's how I would design this API, you know, to be both it was already non-allocating, but just more explicitly, hey, you have the non-erroring, the panicking API, and the erroring API. And here we can do if len DST is less than 42, we turn 0, io.error short buffer, right? So this is for reads. Do we have like an error for short writes? It means the write accepted short write. I guess this should be an error short write. And this is actually not even right. This doesn't even fulfill the IO writer interface, because we're actually reading into the buffer, not writing into CFG nav. That's the write method. So this would be read in any case. Yeah, error short buffer. So that means we require the longer buffer than was provided. Yes. Oof, almost messed that up on camera. And here we just do CFG put 42 bytes, DST, turn 42, nil. Easy peasy. This implements and read is supposed to advance an internal like pointer. So this is actually not even a read. This doesn't even implement the read in. So I read, reader from, reader at. So write to, writer to. So I think this could implement the writer to interface. Is the interface that writes the writer, writes data to W intern. So this actually write to W. Writer. Var buff 42 bytes, buff return in 64, right? Return 42. Or then error. Write buff return in 64 and error. And I think this would implement the writer to interface. I guess we can leave them as, it's sort of weird that you're copying. Yeah, sure, let's leave them as, I was thinking whether to make these pointer, but Yagni. And for the append, how can we do this? And do the same thing. I mean, the easiest thing to do would be just, hey, boom, and DST, append, DST buff. Yeah, this is always gonna work, so we can just append just like that. And if it doesn't, it's because you ran out of memory. So return DST, boom. And there you go. That correctly implements both methods, append and write to. This implements the IO writer to interface. So maybe we can do something like var io.writer to equals cfg net5 compile time guarantee of interface implementation. And so we do this instead of having a write method, we have a write to method, so that we correctly like implement the Go standard library interfaces. CFG message 1, again, like let's do put, and this is going to be 8 bytes, 9 bytes, put 9 bytes. Like, why are you including an error returning interface? If you're going to panic, if you want an error returning interface, we can do, write to or append. Same here, but you get that gist. Same here, like this should be put. Is this arbitrary length? Oh, okay. So this actually might be a good chance for an append method. So when you have variable length data, put is not a good option, because put is for when you know how many bytes you're putting in, so the user doesn't have to do the calculations. If you're going to do put here, I mean, you're going to have to add a method for calculating the length of the buffer beforehand, and It's just so much boilerplate. You might as well do append and let the Go runtime take care of the length. That's a wonderful thing about append methods. Like you just let the runtime take care of how long the buffer is going to be. So here it really looks like this guy should have an append method, but yeah, these should definitely not be right. So I'm now thinking whether this should be, should we have a put method? Probably not. Append is better. How do I usually? Yeah, because I mean, append, you don't want to append on every single variable length data object like this, because maybe you get a glitch and you get like 100 CFG GNS config block types and you use append, and then like it just allocates a huge buffer because you had a glitch on the network. And so it's not a great approach either. You could go for put. I think you could go for put. That returns an error, right? I think that would be a good way to deal with this. Put, return an error. So this would not panic under any circumstance, but it would do like, so there's an easy way to check length. And we can actually add this as a method. Func CFG GNSS length size. Size is what we in Go do for byte. So this is size returns length of GNSS in bytes when sent over the wire. And here we can do, so we have 10 bytes. So this is going to be return 10 plus the amount of config blocks times 8, it appears, times len cfg dot config blocks. Just put the 8 in front. So size cfg dot size if len buff less greater than size, and we just omit that. You know, for debugging, you'd like to have variables you can just step on, although this is going to be usually be on embedded systems. But yeah, this is nice. So return io.error short buff, and we can like make use of the standard library errors here. No. And this should not panic, right? Because this is always gonna fail here if we've done our size calculation right, and I do believe we've done it correctly. So, and another thing, why are you putting like pointers on your arrays? I'm gonna go ahead and take a wild guess and say you don't really need to do that. And besides, like all your methods so far are on copy on non-pointer types, so yeah, you definitely don't need that, my guess. Put. And so now, haha, this is so nice because we know this is not going to fail, because we know if this buffer allocated, we got 64 bytes. We don't have to do expected. We don't have to do any of this error checking because we know this function does what it says it does, or else it panics. And it's not going to panic because this would panic before this function panics. So this is wonderful. You have less logic, just all across the board, right? There's nothing, no checking in here. It's just straight up copying. Some of you might wonder why I did this. This is to omit bounce checking on all of these calls. So since we are bounce checking at the start of this function, Go knows to not insert bounce checks for any of these. And it just reduces code size and speeds things up. I mean, if this is gonna panic if the buffer is less than 42 bytes in length, but it would have panicked anyway by here. So it's just overall win-win. If you're going to panic early and just make the program faster. All right. And do less work in case you're going to panic because you might be able to recover from that panic. I might actually make a branch with this. It's going to be much more illustrative if I make a branch. Here we go. Again, just put. And this isn't unexpected error. Buffer too long. Data too long. There we go. Yeah, as I suspected, there really is no reason to put these as non-pointer types. Again, put, right? You now have the put method, error, and if error is not nil, t.error, fatal. And we like fatal here because if this failed, we know that no data was written, so there's no sense in continuing the test. Net HTTP. Why are we using HTTP here? That's crazy. I must have inserted, when I was checking the errors on HTTP. Okay, set flight mode. if you're gonna, yeah, don't leave me guessing. It's a constant buffer size. I mean, if it's gonna be a constant, just put in your device struct, right? No need to allocate. And this was added 5 years ago. Okay, here we're doing more put 42 bytes. Right, no need to check for errors, no need to check if the length of, so simplify everywhere. Same here, put, and this is arbitrary length. So likely buffer too short for data. And so, yeah, I'm thinking we're gonna have to rewrite these. Put 42 bytes, we know this is put 42 bytes, and then send 42 bytes. Simple message rates. Yeah, I really don't like global variables. This is probably something that, you know, if we ported this from C++ and then C++ does it, so we do it, but likely don't want to expose it. And if we do, we can expose it as a function, as I've shown up here, you know, flight mode CFG. Anyway, let's continue writing these. GNSS disable command, put, and this actually returns an error. So this would have panicked actually before. So this is an improvement. D.buffer, no error. Return if error is not nil. Return error. And we can have a little print ln here. Since this is constant, right? Constant. Again, another reason to have these be functions or not exported, because you can guarantee they'll remain constant throughout the lifetime of a program. Where was I? So if these are not constant, so we can guarantee these are going to be constant if we just, you know, make these not exported. So we can just do GNSS. Maybe that's what we gotta do. Maybe we just gotta unexport these, and just to guarantee they'll remain constant. No one's gonna be touching these. You know, you do get like people who are not as experienced in TinyGo, and they sometimes touch things, or Go for that matter, just not experienced programming, and they think, oh, I'll edit this so I can modify how my message works, my GPSS works. It's like a clever hack, and then all of a sudden your program starts panicking. So yeah, I'd unexport these. This is probably gonna be optimized to be on the stack. And we can make it more explicit by doing that, so it's an array. But how long are these? This is, oh, it's 3 bytes each. Yeah, this is very likely gonna be on the stack. So yeah, I mean, that's just gonna confuse people. It's gonna be on the stack. Put 9 bytes. What is this person doing? It's putting, sending. Okay, so we can do put 9 bytes and send 9 bytes, and just bada bing bada boom. You can even like ensure that this writes 9 bytes. This really looks like just a C++ port gone wrong. I mean, do we want these to be functions? This is a concrete type. We can add methods on this. Why are we device, and why is it not taking a pointer? If this should take yeah, this definitely should take a pointer. Oh, I'm sorry, I'm getting a bit frustrated. Again, why are these not methods on device, and why is it receiving a, yeah, this it's so odd that we chose not to make these pointers, but here we are. And also global functions. Why? I need to know why. CMD buffer. And we're putting them in here. Put 9 bytes. And since we know we're putting 9 bytes in, put 9 bytes. And here we set 9 bytes. Maybe there is sense in actually having this receive a device, but it should receive the pointer type. You know what? Var buff 9 byte. Why are we not? If this is going to be a function, because maybe in the future we have lock to device, and this is like a high level function. You know, it does operations with the device. So I guess this makes sense. I guess it makes sense. You know, send command should definitely, yeah, this should definitely be a method on device. And I feel like there's no doubt on that. This is a single command, so this makes sense to have it be a method, d.send command. And yeah, this does make sense to have it be a high level. Yeah, that makes, I can live with that. And we do the same thing, buff, and we can, oh, okay, CFG, so I'm thinking out of the box. So set CFG ones. So D device and commands. CFG message 1 error. And here we have var buff. And we've maybe, you know, made stuff much more reusable, I guess. Set CFG ones, D commands, and we just do that. Return, much more reusable, I guess. Return set CFGs ones, D comma commands. All right, yeah, this is looking good. Yeah, maybe we can do this. Like, no reason to do it really, but there we go. Send command, d.send command, and this, yeah, this looks like this is a method on device type because it's a single command. In the future, if you want to lock it, it makes sense. Send command 42. It's also you know 42 bytes. We can use that buffer and just return. All right, I'm feeling good about these changes. CMD.put 9 bytes. This is funny, you know, it's using more expected 9 bytes. So it's funny, like, you know, it allocates 9 bytes even though, you know, it knows it needs just 9 bytes. I'm talking as if I knew this was made by an AI. I'm sorry, I've been getting that feeling for quite a while now, and I just am unable to not say it out loud. CMD.put, so then we do, oh, that's it. You know, that's all we need to do. Oh, why not? Less of a diff. Okay, we put it 6 + 4. Yeah, I guess we could do GNSS to size. Also, why not constant? So I can mouse over and see, oh, 50 bytes. Yep, that's good. And then we have this write. And here we're going to do CMD put 9 bytes, buff. Man, I really like this pattern. Put 9 bytes. It's very explicit, you know, 9 bytes, not 9 symbols, 9 bits, 9 bytes. We're putting 9 bytes in here, and we don't have to check any more errors. CMD.put 9 bytes, buff. All right, I really like where this this PR has gone. You know, we've flight mode CFG. I guess we can leave that exported. Does anyone need this? Do we need this? I don't know. We do. I mean, the question is, does the user need it? I'm not buying it. We can put this on the bottom because usually in Go we write the high level functions and then the lower level functions later, since we don't need to. There's no order of declaration. It doesn't matter. The order of declaration does not matter. It's just all part of the namespace and evaluated at the same time. But it's a bit more complex than that, but that's the general just to get an idea of why I did that change. And I feel like this is better. All right, I'm gonna close this git status. You know, where are we right now? Git switch, GPS, UBX, suggestions, git add, git commit, apply suggestions from apply suggestions by Pato, git push, and then and we've been recording for, I think we can end this video right here and leave the next PR for later. Let's see if I get a little, and we're gonna actually like merge it onto Ron's changes. Apply suggestions by Pato for UBX support. GPS UBX support. Hey, uploading a video soon. Explaining these changes. And that's it for this video. Thank you for watching. See you in the next one.